Okay, so for our notes for this week and for the next 2 weeks, this is for what we call transformations. When something transforms, it means it changes somehow. Okay, so transformations. If you want to put that title at the top of your notes, it's a good idea. There are 4 different transformations: a translation, rotation, reflection, and dilation. Okay, all 4 do something different with a shape. First, we're going to talk about our vocabulary terms, though. Does anybody remember what congruent is? Equal. That's a good way to put it. Congruent specifically, since we're talking about shapes on a graph or angles, we want to say that congruent is equal, but we specifically want to say that it stays the same size and shape. Everything about it stays the same or equal to what it was. Does anybody know what similar is then? Yeah, something about them will be different. Okay, so similar means that it's the same shape, but could be a different size. Okay. But everything means it will be proportional. And that just means that the angles are the same and our side lengths will have the same proportion. So let's say our side lengths are 5 and 10. That would be proportional to a side length of 10 and 20. We just doubled it. All right, what does it mean to be parallel, for lines to be parallel to each other? Think about whenever we talked about systems of equations and they had parallel lines. What was special about them? Why did it not have a solution?
Because it just went on and on and on.
And they never what?
Stopped.
To each other. They never crossed each other. They never intersected. So parallel lines, it means that they never intersect. They have the same slope. All right, now we're not talking about prime numbers, okay? We're talking about prime in terms of shapes and geometry. First, it's a symbol, and it tells us whether it's the original shape or we've already done something to it. So, for example, if I say I have angle A, and this is angle A prime, this symbol here is the symbol for prime. It means that we have done something to it. So if I said, here's angle A on this triangle, and then we rotated that triangle, and if I was talking about after it was rotated, I would say this is angle A prime. Okay, it means that it has been changed. Somehow. Even though it might still be the same measurement and everything, we've done something to it. Something has happened. Okay, now translation. You can think about translation if you have trouble remembering what it is. Whenever we translate languages, we just are saying the same thing but in a different language. We're moving from one word to a different type of word. Translation is just what we do with a shape, slide it. So from one position to a different position, but it doesn't change what it is. Okay, so let's say I wanted to take rectangle ABCD, and if I slid it over to the right, sliding it to the right. Does it change? No, nothing about it changed except for its location, right? Okay, so if I slide it back, it's still the same. So for this one, did the angles, the sides, and the parallel sides all remained the same. If everything about it remains the same or equal to what it was, then that means that translations are all what? Now look at your vocabulary terms at the top. Translations are what to each other? They are congruent. If everything stays the same, it's congruent. Okay, rotation. If I'm rotating something, okay, so if I rotate this, it's turning. Did it change at all? Just its orientation, nothing about the shape changed though, right? Just its location. Okay, so rotation is just a type of turn. And everything remains the same. So rotations are also what? Okay, now we have reflection. When we look in a mirror, we see a reflection. It's identical to whatever was placed in front of that mirror, right? A reflection, you can also think of it as a flip. The image is flipped over. So if I reflect this shape, does anything about that shape change? So if I flip this over just across the page, say from here to here, you can see that the shape is still here. Did anything about that shape change? No. So everything remains the same. And reflections are what? Congruent. So far, everything's been congruent, right? Nothing is actually happening to the shape except for changing its location or orientation. All right, does anybody know what a dilation is? What is a dilation?
Like dilation your eyes, so maybe like bigger, smaller.
Yeah, so your pupil of your eye changes size depending on how much light is in the room, right? So she's right, it is the change in size. So for a dilation, it can get larger or smaller. So you can think of it as an enlargement. It can enlarge or shrink. Okay, so when we enlarge something, think of it like multiplying it by a factor. To enlarge something, you need to multiply by a number bigger than 1. And if I wanted to shrink something, what would I need to do? Multiply by a number what? Yeah, less than 1. We're talking about positive values. So if I change the size of this, okay, let's say I shrink it by 1/2. This is just a guess of what it would look like. This is A prime, B prime, C prime, and D prime. These are still going to be the same angles. They're still 90 degrees because it has to stay the same shape, right? I just changed its size. So the angles stay the same. Did my sides change? Is BD still the same length as BD prime? No, they're different. So these change. The side lengths change. What about my relationship of parallel sides? Is AC still parallel to BD on AC BD prime? Is this being parallel still parallel over here? Yeah, so that stayed the same also. So dilations are what? Similar. They are similar, but they are not what? What's the term for that? Congruent. They're similar, but not congruent. So dilations are the only ones that we've talked about where it's going to be similar and not congruent.